Welcome, my dear students. Myself, A. Venkatesan. In this video, we are going to learn differential geometry. In differential geometry, few topics we are going to see here. First one, what is arc length and the formula for arc length, and some problems based on arc length. So now we're going to find arc length of the curve between 2 points. So now we consider the curve of class greater than or equal to 1. So let us the equation of the curve be write r vector equal to capital R vector of u. Suppose it is required to find the arc length between the point capital A and capital B on the curve for like equation 1 corresponding to the values A and B of a parameter u. Let we choose the curve possibly A equal to the starting point u0, comma u1, u2, etc. un minus 1, comma un equal to the last point B, where it looks like u0 less than u1 and u2 less than u2 and un minus 1 less than un be any subdivision of the interval. So now we're going to see the curve. So it looks like the curve form. So we are taking the curve from A to B. That curve can be joined by some different curves, that is A0, A1, one of that curve, A1 to A2, A2 to A3, etc. an minus 1 to an. Thus we get the polygon inscribed to the arc by joining the successive point like A0, A1, etc. an. So now we are going to find the length of the arc from the point from capital A to capital B. So that is equal to, that is now we are going to find the length from A to B. So it is, we can use by simplification way, that is we find A0 to A1 and A1 to A2, A2 to A3, etc. So that is right the distance between A0 to A1 and distance between A1 to A2, A2 to A1, A3 to A1, etc. That is we write the length mod A0 A1 vector plus A1 A2 vector plus etc. an minus 1 an vector. Simply we can write this one as summation I from 1 to n ai minus 1 to ai. So that is we denoted as L delta, that is length of the arc from the difference del equal to summation I equal to 1 to n mod r vector of ui minus r vector of ui minus 1. So it can be used some few things. So if you increase the number of points of the subdivision, the length of the polygon will be increased because sum of the two sides of a triangle is greater than the third side. So therefore we define the length of the arc to be the upper bound taken overall possible subdivision of the interval closed interval a comma b. So therefore from equation 2 we may write that, so that is it can be changed by using integral way. So this can be written as, that is r vector of ui minus r vector of ui minus 1 can be changed integral from ui minus 1 to ui dr vector by du into dv. Suppose if you integrate the term, we can get again the previous one. So now we apply this integral. So we know d differentiation with respect to u means it is notated as r dot. So therefore it is dr by du is r dot of u vector. Summation I equal to 1 to n mod ui minus 1 to ui r dot of u into du. By Quotient inequality, it should be less than or equal to summation I equal to 1 to n integral ui minus 1 to ui mod r dot of u into du. So now we expand this integral. First limit u0 to u1, next u1 to u2, etc. ui minus 1 to ui. So we combine all the terms. So we will get u naught to un mod r dot of u into du. We know what is u naught. U naught is a starting point A and un is the ending point B. So therefore we write this integral as integral A to B mod r dot of u into du. So that is L delta is less than or equal to integral A to B r dot of u into du. What it says this equation? So in this equation, the right hand side of 3 is finite and it is an independent of delta. So the upper bound of L delta is always finite. So now we are going to show that the upper bound of L delta is integral A to B r dot of u into du. So now let us choose the arc S equal to S of u at the point A to any point u. That is the arc length from u naught to u is S of u minus S of u naught, where u lies between u naught to un. So therefore we write the difference of this arc S of u minus S of u naught less than or equal to, you know this integral value, u naught to u mod r dot of u into du. But we know r dot of u minus r of u naught is less than or equal to S of u minus S of u naught. So from this equation 4 and 5, we will get mod r vector of u minus r vector of u naught less than or equal to S of u minus S of u naught, and this one is less than or equal to integral u naught to u mod r dot of u into du. So now we divide u minus u naught from the above equation and we are taking the modulus of this equation. Then we apply limit u, taking limit as u tends to u naught. So we get mod limit u tends to u naught r of u minus r of u naught divided by u minus u naught, which is less than or equal to limit u tends to u naught S of u minus S of u naught divided by u minus u naught, which is less than or equal to limit u tends to u naught integral u naught to u mod r dot of u divided by u minus u naught into du. So that is mod r dot of u naught less than or equal to S dot of u naught, which is less than or equal to mod r vector dot of u naught. So we know vector notation, it is represent dot means differentiation with respect to u. So therefore by the inequality process we may write S dot of u naught equal to mod r dot of u naught. So this can be written as ds of u divided by du equal to mod r dot of u naught. So we want S of u only. So now we integrate with respect to u. So therefore S of u equal to integral u naught to u mod r dot of u into du. So therefore S equal to u naught to u mod r dot of u into du. So which is the arc length form for any two point. So now we find the result for what is the value of r dot of u. We know the curve r equal to r of u. R of u equal to x of u plus y of u plus z of u. Simply we note it as r of u equal to xi vector plus yj vector plus zk vector. So r dot means differentiate partially with respect to u. So differentiate partially with respect to this vector means we know the class function. So it is differentiable each component, that is x component, y component and z component. So therefore we may write x dot, y dot and z dot. So x dot I vector plus y dot j vector plus z dot k vector. So that is mod r dot of u equal to square root of x dot square, y dot square plus z dot square. So therefore this equation arc length may be right S equal to integral a to b square root of x dot square plus y dot square plus z dot square into du. So which is the required equation for to finding the length of the arc in a curve between any two points. So now we are going to see some examples. Obtain the equation of circular helix where r equal to a cos u, a sin u, bu, where u lies between 0 to infinity and where a is greater than 0, refer to SS parameter and show that the length of the one of the complete turn of the helix is 2 pi c, where c equal to square root of a square plus b square. So we take any circular helix and only going to find one complete turn. So we know the circular helix, for example, simply we know the mosquito coil. So it is the best example for the circular helix. Now we are going to find the simple single turn only. So given circular helix is given, so the equation of the circular helix, r vector is given, vector component. So r vector equal to a cos u, a sin u, du. So x component x equal to a cos u, y equal to a sin u, z equal to bu. So we know the arc length form, s equal to s of u equal to integral 0 to u square root of x dot square plus y dot square plus z dot square into du. So here the limit is varies from 0 to u. So one complete turn. So therefore 0 to u square root of a square sin square u plus a square cos square u plus b square u plus a square sin square u. Simplification, we can get the value, limit is 0 to u square root of a square plus b square into du. So that is equal to integral 0 to u c du, because the given hypothesis where c equal to square root of a square plus b square. So now we integrate the term, we get u, and after applying the limit we get u's. So that is s equal to cu. In general way this is, but we need only one complete turn. So one complete turn means it is found at 360 degree. So therefore the limit is varies from 0 to 2 pi. So therefore we can choose the limit u belongs to u0 to u0 plus 2 pi. Therefore we apply the limit from u equal to u0 to u0 plus 2 pi. So therefore we simplify the term, s equal to 2 pi c. Therefore the one complete turn of the circular helix of arc length is 2 pi c. Similarly, we are going to find another one problem. Find the length of the curve given as the intersection of the surfaces x square by a square minus y square by b square equal to 1, comma, x equal to a cos z by a from the point a, 0, 0 to the point x, y, z. So yes, we know what is s. S arc length. S is equal to integral 0 to u mod r dot of u into du. Given x equal to a cos h of z by a. So now we take that z by a as a u. That u equal to z by a. This implies that z equal to ua. So we substitute this value in equation 1. So that after simplification we can get the value of y equal to b sin hu. So therefore that x value is a cos hu, y value is b sin hu, and z value is ua. So therefore we get x, y, z. So we know s equal to square root of integral u to u0 square root of x dot square plus y dot square plus z dot square into du. So therefore x dot is minus a sin hu, y dot is b cos hu, z dot is a. So therefore mod r dot of u equal to square root of a square plus b square into cos hu. So now we apply this integral. So we are changing the limit. So now we are going to change the limit of the integral when z equal to 0 and z equal to z. So z equal to 0 means au equal to 0. So that is u equal to 0. If z equal to z is au equal to z. So is u equal to z by a. So therefore limit is 0 to z by a. So mod r vector dot of u into du. So that is 0 to z by a square root of a square plus b square into cos hu into du. So we simplify the term. Integrating cos hu is sin hu. The limit is varies from 0 to z by a. So sin 0 value 0. So therefore we can get the value s equal to square root of a square plus b square into y by b. So which is the required equation of the arc length. Thank you.